number 9. Question number 9, they are telling us that the graphs F is drawn below is that, and G is that at the intercepts. First question, can we show that A is 1, B is -3, and then C is -9? So the approach to this is 1. When you look at E is an intercept, but at the same point, it's a turning point, which plays a bigger role. That this, if we are to get the factors of that, it's just going to be x plus 1, but squared. And then I'll multiply it with x minus 5. In other words, this is going to be the equation of F. What we need to do, just open this up and make sure that we end up with these values. Then we shall compare with the original. So when I open the first one, that's going to be x squared plus 2x plus 1. Then I'm going to multiply it with this. So when I open this up, it's going to be x cubed minus 2x squared plus x. And then minus 5x squared minus 10x minus 5. This is going to be x cubed minus 5x squared. This and this is giving me a -9x and then minus 5. So this is my new equation. When I compare it with the original that was given, which was ax cubed plus bx squared plus cx minus 5, we can see that a is a 1, b is a -5, and then c is a -9. The d automatically came out. So in that what they, why are they having a 3? Oh, what did we do wrong? For b squared. No, we have to go back. We have to go back. Something is off. Something is off. What did I do wrong? I'll erase this. I'll erase that and reopen this bracket again. So we're saying x and that is x cubed, this and this, plus 2x squared, this and this is plus x. Okay, then 5 and that is minus 5x squared minus 10x minus 5. Okay, so it's x cubed. So this and this is minus 3x squared minus 9x, then minus 5. Why is everything in minus minus? Does it make sense? Maybe, most probably. So the a is a 1, the b is a -3, it's not a -5. My apologies, c is -9, and then the d is negative. So that is how we would have proved that. Then calculate the value of x for which f has a local minimum. So when you talk of a local minimum, they're focusing on the turning point. Okay, turning points. So I'll need to get the first derivative. So that's gonna be 3x squared minus 6x minus 9 is equal to 0. I'll divide through by 3, x squared minus 2x minus 3 is a 0. Open this up, x minus 3, x plus 1. So which means x is a -1 or x is a 3. What do they want? The value of x for which it has a local minimum. So which means x has to be a 3 at this point. Okay, the -1 is already at point E. Okay, then use your graph to determine the values of x for which the second derivative concavity times the function itself will be greater than 0. So there are two aspects to this. So I can say that my f double prime is greater than 0, or my f of x is less than 0. Second approach is f double prime is less than 0, or my f of x. But why am I saying that? If it's greater, this must also be greater, since it's greater than 0. And then if it's less, then this must also be less than 0. Okay, now where do we find those scenarios? So we already have the first derivative to be this. No, that's not true. First derivative to be 3x squared minus that minus that. And then our second derivative is going to be 6x minus 6. Okay, so if I have my 6x minus 6 to be greater than 0, which means x has to be greater than 1. And then where do I find the graph of f to be greater than 0, to be above 0? It's at this point where the graph is above or beyond 5 for x above 5. So x must be greater than 5. And then if it's concave down, it's going to be x is less than 1. And then where do I find the graph of f to be below 0? To be below 0 is less than this. So I'm going to say x must be less than 5. X cannot be negative 1. I can use that as well. Okay, x is greater than 5, x is less than 5, and so on and so forth. So those are the sorts of solutions I would have. The 9.4, for which values of t will this have two positive distinct roots and a negative? So which means this graph needs to be moved. Okay, so the t is just a shift within the vertical. So this is going to be negative 5 from f if x is a 0 everywhere. And that's going to be negative 5. What we need to find is what is the value of the y at the turning point, or what's the minimum value. So if x is 3 for f, I'm going to say f of 3. Okay, what is the f of 3? That's going to be 3 cubed minus 3 times 3 squared minus 9 times 3 minus 5. This gives me negative 32. So this graph must be moved between negative 32 and negative 5 upwards, because if it goes beyond or below that, then we're going to have something different. So I'm going to say negative 5 must be less t, then must be less negative 32. Okay, so that's question number 9. Question number 10, EHGF. EHGF is a rectangle, and we know some properties of rectangles. Okay, is produced x squared